All right, so get this. We're diving into some seriously mind-bending AI research today.
Oh, yeah.
Yeah, it's called Socratic Learning, and it's got some pretty wild implications.
Like what?
Well, imagine an AI locked in a virtual room,
Yeah.
no access to the outside world,
Right.
but somehow it keeps getting smarter.
Sounds impossible.
Yeah, right? That's what makes it so fascinating.
I can see that.
So we're exploring this recent paper titled Boundless Socratic Learning with Language Games. And let me tell you, it's a real head-scratcher.
Well, what's really cool is that this paper, it's not just theoretical.
Oh,
Yeah. It's grounded in the advancements we're seeing in AI,
makes sense.
specifically large language models.
LLMs?
Exactly.
Yeah.
You might have heard of them. These AI systems that can generate human-quality text, translate languages, write different kinds of creative content.
Yeah, I've heard of those.
But what if we could use these LLMs to create AIs capable of self-improvement?
Even within a closed system.
Yeah, that's the core idea here.
So to be clear, by closed system, we mean this AI isn't getting any new data.
Right.
No internet access, no new books to read.
Exactly.
It's all about what it can learn from what's already inside its brain, so to speak.
Think of it like a seed
Okay,
with all the genetic information packed inside that it needs to grow.
I like that analogy.
Now, the paper outlines 3 crucial conditions for this kind of self-improvement to be possible.
Okay, let's hear them.
First, you need feedback. The AI has to know if it's heading in the right direction.
Like a personal trainer.
Exactly.
Yeah.
Someone who can tell you if you're getting stronger or just spinning your wheels.
Right, that makes sense. But even with feedback, couldn't the AI get stuck exploring the same limited set of ideas?
That's where the second condition comes in.
Which is
Coverage.
coverage.
It's all about ensuring the AI explores a broad range of possibilities.
I see.
Kind of like a curious explorer venturing into uncharted territory instead of sticking to familiar paths.
That's a good way to put it.
And this is especially relevant when you think about the example the paper uses, an AI tasked with proving the Riemann hypothesis.
Oh, wow. Now, I'm no mathematician,
You neither.
but I know that's one of those big unsolved problems that's baffled mathematicians for over a century.
Yep.
You're saying this AI, locked in its little virtual room, could potentially crack a problem that stumped some of the greatest minds in history.
Well, the paper suggests it might be possible.
How?
Imagine this AI isn't just crunching numbers.
Okay.
It's engaging in a kind of internal dialogue, using mathematical language to form hypotheses, test proofs, and refine its understanding.
So, like, it's constantly debating with itself.
Yeah, challenging its own assumptions
Yeah.
and exploring new avenues of thought.
And with enough computational power?
Yes. The third condition, scale.
Right, scale. This AI could theoretically explore a vast landscape of mathematical ideas and potentially stumble upon solutions we haven't even thought of.
Exactly. It's pretty mind-blowing.
So we've got this feedback, this constant push for exploration, and then this massive computational power to fuel it all. But how does Socratic learning fit into all of this?
Good question.
The title mentions language games. What's that all about?
That's where it gets really interesting. The paper proposes that the key to this kind of self-improvement lies in language games.
Right.
These are structured interactions where the AI uses language as both input and output.
So it's like playing a game.
Kind of. But instead of moving pieces on a board,
Yeah.
the AI is generating language, receiving feedback, and refining its understanding through this back and forth.
So it's learning through conversation.
Essentially, yes.
Yeah.
But who is it conversing with?
Itself.
In a way, yes. It's engaging in this internal dialogue.
Okay.
But the structure of these language games provides the framework for meaningful learning.
Give me an example.
Sure. Like, if you wanted to become a better writer,
Okay.
you might practice by writing different forms of content.
Poems, essays, scripts.
Exactly. Each form has its own rules and conventions, right?
Right.
Pushing you to develop different skills.
Makes sense.
It's the same with these language games. Each game challenges the AI in a unique way, helping it to refine its use of language and ultimately its ability to think and reason.
And how does this connect to the AI proving the Riemann hypothesis?
Remember that example of the AI working with a proof verifier?
Yeah.
That verifier is acting as a judge in a very specific language game.
I see.
The AI presents a mathematical proof,
Uh-huh.
and the verifier determines if it's valid or not.
Right.
And through this repeated interaction, this game of proof and verification, the AI gradually builds its knowledge and refines its understanding of the problem.
Okay, so I'm starting to see how these language games can drive the AI's learning, but the paper also talks about potential challenges. Didn't it mention something about ensuring the AI doesn't get stuck in a rut?
Yes. Even with these games in place, there's a risk that the AI could become too focused on certain types of problems or solutions,
Okay.
neglecting other potentially fruitful avenues of exploration.
So it's like a chess player who only studies one opening move.
Exactly. They might become really good at that specific scenario, but they'll be ill-equipped to handle unexpected challenges.
So it's not enough to just have these games. We need to make sure the AI is playing the right games.
Precisely. The ones that will challenge it in the right ways.
That's a pretty big challenge. How do we design or select these language games so they lead to beneficial outcomes? Games that will push the AI to think creatively and develop the kind of intelligence we want to see.
That's one of the big open questions in this field.
I bet. And I'm guessing the paper offers some potential answers or at least some promising directions for research.
It does. And that's where things start to get really mind-bending. Because the paper doesn't just talk about designing language games.
What else?
It explores the possibility of the AI choosing its own games,
Seriously?
or even creating entirely new games.
Wait, hold on. The AI designing its own games, isn't that like letting the student write their own exam?
It's a radical idea, but it's also one of the most fascinating aspects of this research. Imagine an AI that can not only play these language games, but can also analyze its own progress, identify its weaknesses, and then design new games specifically tailored to address those weaknesses.
That's incredible. It's like giving the AI the keys to its own learning process.
Exactly.
Letting it become its own teacher in a way.
And that takes us to the next level of this deep dive, self-referential systems.
Ooh, that sounds intense. You're going to have to break that one down for me, but let's save that for part 2.
Sounds good.
For now, I need a moment to wrap my head around this whole AI designing its own games thing. It's like something straight out of science fiction.
I know, right? It's wild.
It really is. Okay, so last time we were talking about AI systems that can design their own language games.
Yeah, it's a pretty wild idea, right?
Totally wild. Like, we're talking about AI that can not only learn,
Right.
but actually shape its own learning process.
It really challenges how we think about intelligence and learning.
You mentioned self-referential systems. What exactly does that mean?
Well, a self-referential system is basically a system that can refer to itself.
Okay.
It can analyze and modify its own structure and behavior.
So in the context of AI,
Right.
you're talking about an AI that can understand and maybe even alter its own code.
Exactly.
Hold on. An AI rewriting its own code? Isn't that kind of dangerous?
I know it sounds a bit scary.
Like, we're giving the AI the power to completely change the rules of the game.
Yeah, I get that concern. But it's important to remember that we're not talking about some rogue AI suddenly becoming self-aware.
Okay.
It's not about giving the AI total control.
So what is it about then?
It's about enabling the AI to make targeted changes to its own learning process.
Okay, that makes me feel a little better. But how do we even design AI systems that can do that?
It's definitely complex, but recent breakthroughs in AI, particularly with LLMs, have made it more realistic.
Right, LLMs, those large language models we were talking about.
So remember, LLMs are already really good at understanding and generating human language.
And code, too, right?
Yes. Code is essentially just another form of language, the language of computers.
So the same AI that can write a poem could potentially analyze and modify its own code.
That's the idea.
Yeah.
And it opens up some incredible possibilities.
Like what?
Imagine an AI that can identify its own limitations and then rewrite itself to overcome those limitations.
It's like evolution and fast forward.
Exactly. The AI driving its own adaptation.
So how would this self-modification work with language games?
Let's go back to the proof verification game.
Okay.
Imagine the AI is playing that game.
Mm-hmm.
As it plays, it analyzes its performance and figures out where it struggles. Maybe it's having trouble with a specific mathematical concept.
Right.
With self-modification, it could rewrite parts of its code to understand that concept better.
So it's not just about getting better at the game.
Right.
It's about changing how it approaches the game altogether.
Right. It could develop new strategies or even new ways of thinking.
So this all ties back to coverage.
Yeah. Exactly.
Right.
By letting the AI modify itself based on its experiences in these games, we're helping it explore a much wider range of possibilities.
This is all so fascinating, but it also sounds a little risky.
Oh yeah, for sure.
If we give AI this much power, how do we make sure it doesn't become harmful?
Well, that's the big question, isn't it?
It is.
The paper talks about the need for careful design and oversight.
Makes sense.
One approach is to set boundaries on what the AI can modify.
So putting some limits on its power.
Exactly.
What else?
Another approach is to focus on developing AI that's aligned with human values.
So if the AI shares our values,
Right.
it's less likely to go rogue.
That's the thinking.
It seems like we're entering a whole new era of AI research.
We are. It's really exciting.
But also a bit scary.
Yeah, for sure.
It's like we're shaping the future of intelligence.
And that's a huge responsibility.
Well said. So beyond all the philosophy, what are some real-world uses for this kind of AI?
The possibilities are endless. One area is scientific discovery. Imagine an AI that can analyze huge amounts of data, find patterns, and come up with hypotheses.
That's cool.
And it can constantly refine its methods based on what it finds.
So it's not just crunching numbers.
No, it's actually contributing to science.
It's amazing. And what about other fields?
Think about education. An AI could personalize learning for each student.
That would be incredible.
Or creative industries. An AI could work with artists and designers to push boundaries.
So we're talking about a real revolution in how we learn, create, and solve problems.
I think so.
But let's get a bit more technical. You mentioned LLMs are key to all of this. Can you explain more about how they work and why they're so important for this research? Welcome back. So we've talked about AI learning in a closed system.
Right.
Even AI designing its own learning. Now let's look at what makes it all possible. LLMs.
Large language models. The engine behind all of this.
They're pretty amazing, right?
They are. Basically, they're algorithms trained on tons of text data.
And that lets them understand language.
Exactly. They learn the nuances, the patterns, how language conveys ideas.
But it's not just about natural language, right?
Nope. LLMs are also getting really good at understanding code.
Code, like computer code.
Yep. Which is basically another type of language, the language computers use.
So the same AI that can write a story can also understand how a computer program works.
Pretty much. And that's crucial for Socratic learning and self-modification.
How so?
Remember, the AI is always learning through language, playing those language games.
Right.
But if it can understand code, it can go even further.
What do you mean?
It can analyze its own code.
Wow.
The instructions that control its behavior,
Okay.
find inefficiencies or limitations, and modify that code to get better.
It's like the AI is looking at its own blueprints and making improvements.
Exactly.
Yeah.
But that requires a really deep understanding of code.
Yeah. Code can be super complicated.
It can. And that's where LLMs come in. They allow the AI to not just read code, but to understand its meaning.
So it's not just about seeing the code, it's about getting the code.
Right. They can see how different parts of the code relate to each other.
Okay.
Understand how changes in one place affect other places.
Makes sense.
And even write new code to do specific things.
So it's like we're giving the AI a toolbox to tinker with its own inner workings.
A pretty powerful toolbox.
But that sounds a little dangerous too.
It can be. We have to be careful.
How do we make sure the AI doesn't misuse this power?
That's a key question. One approach is to set limits on what the AI can change.
Like safety measures.
Exactly.
Yeah.
For instance, you might stop it from changing code that controls its core values.
Or how it interacts with the real world.
Right. We don't want it going rogue.
So we're giving it access, but with some restrictions.
A controlled environment.
But there's another approach too, right?
There is. We can focus on building AI that's aligned with human values.
So it's not just about stopping it from doing bad things.
Nope. It's about making sure it wants to do good things.
Making it inherently good.
If we can get the AI to share our values,
Right.
it's less likely to use its power in ways that harm us.
That makes a lot of sense. But how do we teach an AI about values?
That's one of the toughest challenges. We could train it on data that shows good behavior.
So like showing it examples of ethical decision-making.
Exactly.
Right.
We can also design reward systems that encourage it to act according to our values.
So it's a bit like raising a child.
In a way, yes. We're trying to guide it toward a positive path.
But even with all that, there's still a lot we don't know, right?
Absolutely. There's a lot of uncertainty about the long-term effects of this technology.
It's a big experiment.
It is, but it's also incredibly exciting. We're pushing the boundaries of what's possible with AI.
This whole deep dive has been amazing.
I agree.
We started with AI learning in a closed system, and now we're talking about the future of intelligence itself.
It's mind-blowing. And remember, this is just the start.
There's so much more to come.
We're just scratching the surface. The coming years will probably bring even more breakthroughs.
It's a wild ride.
It is. So as we wrap up, think about this. If AI can constantly evolve its own learning, what does that mean for us?
That's a great question. What does it mean for the future of human learning? For education? For knowledge?
We're entering a new era where the line between human and artificial intelligence is blurring,
It's a future full of potential.
but also challenges.
Yeah.
We need to be thoughtful about how we shape this future.
Well said. So to our listeners, keep exploring, keep asking questions, stay curious about AI.
It's a fascinating field.
It really is. Until next time, fellow deep divers.